So now you might wonder, what is the difference between a data analyst, data engineer, and a data scientist? In simple terms, a data analyst is the one who is able to extract useful insights from a given data set. The data analyst can help companies to analyze market trends, find customer needs, and assess their overall performance. A data analyst can summarize data and help top authorities to take decisions. The most used tools for a data analyst are Python, SQL, and Excel. On the other hand, a data engineer is the one who is able to gather or prepare data for a data analyst or a data scientist for further exploration and analysis. A data engineer is able also to create and maintain platforms for data processing. In other words, he or she can provide the best work environment for data various operations. The common tools for a data engineer are Java, SQL, NoSQL, Hadoop, and Apache Spark. Finally, a data scientist is the one who uses his or her knowledge in statistics, programming, and machine learning to make predictions of the future. A data scientist is able to use machine learning algorithms to understand data patterns and create questions to be answered after data transforming and cleaning. The common tools for a data scientist are R, Python, SAS, SQL, and NoSQL. So let's take this simple example to differentiate between a data analyst, a data engineer, and a data scientist. Let's imagine that we want to cook a meal. The data engineer will get the recipe ingredients according to the data analyst and data scientist instructions. Then after buying these ingredients, the data scientist will be the one who cooks the meal with the help of a data analyst. So now you might wonder, what is data analysis? Simply, data analysis is defined as the process of cleaning, transforming, and modeling data to discover useful information for business decision making. The purpose of data analysis is to extract useful information from data and taking the decision based upon the data analysis. A simple example of data analysis is whenever you take any decision in your day-to-day life is by thinking about what happened last time or what will happen by choosing that particular decision. This is nothing but analyzing your past or future and making decisions based on it. For that, you gather memories of your past or dreams or your future. So that is nothing but data analysis. So now let us answer the question, how data analysis started. To know the history of data analysis, we need to know the history of data itself. It's often said that we are in the age of data. We create, curate, collect, compute, and cleanse more of it every day. Data feeds the growth of exciting technology like artificial intelligence. It helps personalize our online experiences, and it helps us move forward in the quest for more knowledge. But how long has it taken to get here? The concept of data is not new, far from it. In fact, its story dates much further back than you might think. Here, we dive into the long, rich history of data. The ancient world. It's perhaps possible to trace the history of data back to the ancient world as early as 19,000 BC. The Ishango bone was a noticed baboon bone tool dating from around 19,000 BC. It's thought to have acted as a tully stick, so it could be speculated that the Ishango bone represents an incredibly early instance of data collection and storage. That is, those methodical bone scratches could be the first documented record of humans logging numerical information for later use. Early interpretations. In 1663, John Grant conducted one of the earliest recorded instances of data analysis. He studied the death records kept by London parishes. From this, he was able to make observations about the varying death rates between genders and even predict life expectancy. Data processing problems. To solve the data processing problems, Herman Hollerith was the man to solve this problem with his invention, Hollerith machine, which made it possible to process and analyze large amounts of data. A question of storage. So the challenge of processing data had been answered, in some part, by this early automation. The history of data then saw a shifted emphasis into storage and collection. In 1928, Fritz Pilfermer invented magnetic tape for recording purposes, or in other words, a way to collect and store data magnetically. This is an idea that lasted. The hard disk drives, floppy disk, and tapes that would follow toward the end of the century were all enabled by magnetic data storage. The 1960s saw the conception but not the creation of cloud data storage by Dr. Joseph Carl. He invented an integrated computer network where data and programs could be accessed by anyone, anywhere, at any time. This idea formed the basis of cloud computing as we know it today. Then, in the 1970s, Edgar Coded presented a framework for a relational model of database management. This proved an influential theory in the history of data. It's a framework for data management and it's still used today. The Internet. Naturally, the most noteworthy 90 event in the history of data is the invention of the Internet. Sir Tim Berners-Lee created hyperlinks and hypertext, enabling data sharing worldwide. Other notable moments for the history of data in the 19s include 1997, which saw the launch of Google Search. This puts data very much in the hands of anyone with computer access. Also now we know the new concept which has come to surface, which is called big data. Big data has been invented or has been risen by the inventions of social media platforms. Social media platforms record data about every user in this platform. So the big data now has risen due to this. So now you might wonder, what type of questions a data analyst can answer? Let me tell you this. A data analyst can answer 6 different questions. So let's start with them. A descriptive question is the one that seeks to summarize a characteristic of a set of data. For example, what is the sales trend on December? On the other hand, an exploratory question is the one in which you analyze the data to see if there are patterns, trends, or relationships between variables. For example, what is the relationship between A and B? Third, an inferential question would be a restatement of this proposed hypothesis as a question and would be answered by analyzing different set of data. For example, is this drug more effective than the other? Then comes the predictive question. A predictive question would be the one where you ask what types of people will eat a diet high in fresh fruits and vegetables during the next year. Then comes the causal question. A causal question asks about whether changing one factor will change another factor, an average in a population. For example, is smoking causes lung cancer or not? Finally, a question that asks how a diet high in fresh fruits and vegetables leads to a reduction in the number of viral illnesses would be a mechanistic question. So now you might wonder, what are the types of data analysis? For data analysis, there are 4 types: descriptive analysis, diagnostic analysis, predictive analysis, and prospective analysis. Descriptive analysis is the first type of data analysis. It is the foundation of all data insight. It is the simplest and most common use of data in business today. Descriptive analysis answers the what happened by summarizing past data, usually in the form of dashboards. The biggest use of descriptive analysis in business is to track key performance indicators, KPIs. KPIs describe how a business is performing based on choosing benchmarks. Business applications of descriptive analysis include KPI dashboards, monthly revenue reports, sales leads overview. Now let's move to the diagnostic analysis. After asking the main question of what happened, the next step is to dive deeper and ask why did it happen. This is where diagnostic analysis comes in. Diagnostic analysis takes the insights found from descriptive analytics and drills down to find the causes of those outcomes. Organizations make use of this type of analytics as it creates more connections between data and identifies patterns of behavior. A critical aspect of diagnostic analysis is creating detailed information. When new problems arise, it is possible you have already collected certain data pertaining to the issue. By already having the data at your disposal, it ends having to repeat work and makes all problems interconnected. Business applications of diagnostic analysis include a freight company investigating the cause of slow shipments in a certain region, a SaaS company drilling down to determine which marketing activities increase trades. Now let's move to the predictive analysis. It attempts to answer the question, what is likely to happen? This type of analytics utilizes previous data to make predictions about future outcomes. This type of analysis is another step up from descriptive and diagnostic analysis. Predictive analysis uses the data we have summarized to make logical predictions of the outcomes of events. This analysis relies on statistical modeling, which requires added technology and manpower to forecast. It is also important to understand that forecasting is only an estimate. The accuracy of predictions relies on quality and detailed data. While descriptive and diagnostic analysis are common practices in business, predictive analysis is where many organizations begin to show signs of difficulty. Some companies do not have the manpower to implement predictive analysis in every place they desire. Others are not yet willing to invest in analysis team across every department or not prepared to educate current teams. Business applications of predictive analysis include risk assessment, sales forecasting, using customer segmentation to determine which leads have the best chance of being selected. The final type is prospective analysis. It is the most sought after, but few organizations are truly equipped to perform it. Prospective analysis is the frontier of data analysis, combining the insight from all previous analyses to determine the course of action to take in a current problem or decision. Prospective analysis utilizes state-of-art technology and data practices. It is a huge organizational commitment, and companies must be sure that they are ready and willing to put forth the effort and resources. Artificial intelligence (AL) is a perfect example of prospective analytics. AL systems consumes a large amount of data to continuously learn and use this information to make informed decisions. Well-designed AL systems are capable of communicating these decisions and even putting those decisions into action. Business processes can be performed and optimized daily without a human doing anything with artificial intelligence. Currently, most of the big data-driven companies like Apple, Facebook, Netflix are utilizing prospective analytics and AL to improve decision-making. For other organizations, the jump to predictive and prospective analytics can be insurmountable. As technology continues to improve and more professionals are educated in data, we will see more companies entering the data-driven realm. So now you might wonder, why data analysis is important? Data analysis is important because it can help you in 4 different ways. First, data analysis can help you to predict customer trends and behaviors. For instance, Netflix uses data analysis to predict what type of movies you might like to watch, based on your history of watching movies. And therefore, it only brings you movies that are related to your interests. Second, data analysis can help you to analyze data in meaningful ways. For example, you might have a sheet of numbers, but numbers by themselves cannot bring you results or effective information. So by using Python libraries or using Power BI or Tableau, you can analyze data in meaningful ways and find helpful or effective conclusions. Third, data analysis can help you to predict or to increase business productivity. For example, you can study the sales for your business in 1 year and see what are the weaknesses that you can work on to improve your productivity. Finally, data analysis can help you to drive effective decision making. After drawing graphs and visualizations and analyzing these visualizations, you can find effective information that helps you to take sound, effective decision. And now, after understanding the importance of data analysis, let's check together companies that have implemented data analysis in their business processes. Netflix. Netflix utilized the power of their data to run predictive analysis to learn what exactly their customers would be interested to watch. By analyzing over 30 billion plays a day as well as over 4 million subscriber ratings and 3 million searches, they were able to make winning bets on developing widely acclaimed hits, such as House of Cards and Arrested Development. Google. Google's People Analytics team dug deep into their data and analyzed employee performance reviews and feedback surveys amongst many data sources to better understand how to build a better boss. This helped to create a list of data-driven insights into what employees valued and helped to improve the manager quality 75% of their lowest performing managers. But that's not all. Google's use of analytics extended to make key decisions to enhance employee welfare, such as extending maternity leave to cut their new mother attrition rates in half. Coca-Cola. Coca-Cola leveraged the power of image recognition technology and data analytics to target users based on the photos they share socially, giving them insights into the individuals drinking their products, where they are from, and how and why their brand is being mentioned. The personalized ads served this way enjoyed a far greater click through rate versus other methods of targeted advertising. If you ever wondered what a data analyst do, you have to know the following. It takes time to gather, assess, and clean data, but the best part is when you extract the gold information out of the deep ocean of data. So let's start. The first step is data collection and storage. It involves obtaining data, downloading a file from the internet, scraping a web page, querying an API, and etc., and then importing that data into programming environment like Jupyter Notebook, RStudio, PyCharm, and Spark. The next step is data preparation and cleaning. In this phase, data is inspected for two things: data quality issues, like content issues, and lack of tidiness, like structural issues, before moving into the cleaning phase. The cleaning data is applied to the data that were inspected before and solving quality and tidiness issues by help of a programming language like Python and R. The final step is exploration and visualization. In this phase, the data is ready for being visualized using graphs and vectors by the help of a programming language library like Python, which includes libraries like MATLAB and Seaborn, it can be visualized using Tableau or Power BI. These two are two platforms for data analytics visualizations. So, what skills needed for a data analyst? A data analyst must possess both technical skills and soft skills. So, let's first talk about the technical skills. Math and statistics are very important aspects that any data analyst must care about because you are dealing with building models and etc. So, you need to know some math and statistics. There are many sources to learn from, like Udemy and YouTube and etc. Of course, you have to know about Python and R languages. Either you master one of them or both. It's preferred for you to focus more on Python because now businesses or companies use Python more when implementing data analysis projects. R is more for academic purposes and statistical studies. Both are good for, however, both are good for data analysis projects. Then you have to know about data wrangling and pre-processing. It's important for you as a data analyst to know how to deal with data, clean it, and visualize it. Then you have to possess data visualization skills. You should know how to visualize data using either Python libraries, R libraries, or Tableau and Power BI. So this is for the technical skills. For the soft skills, you have to have ethical skills because sometimes you are dealing with data that is so sensitive. So you should be very careful about that. You should maintain the integrity of this data and use it in a good way. Then you have to know how to play as a team player because usually data analysis projects are big, so it needs more than uh, a team player to work on. So for that reason, you have to know how to be a good team player in that specific project. Lifelong learning skills. Data analysis is expanding at every day. So you should continue learning and improve your skills as a data analyst. Finally, communication skills. Because you are presenting your data or your studies to stakeholders and maybe senior managers, so you have to be very good at communication and convince them to believe in your numbers. Lastly, real world project skills. You have to know how to apply your data analysis skills in a real world projects. So now let us continue talking about some of the skills that are needed for a data analyst. The first skill is creativity. When I first started to dig deep in the data science field, I was so worried of the variety of things that I have to learn. There are many programming languages, many statistical methods, and many math equations. I asked myself, how am I supposed to learn and remember all of this? And while I was working in different projects, I used to think of how to solve the challenge here. I started to Google and look for answers everywhere. Then I realized that there are so many solutions and so many tools to help me solve them. I reached the conclusion that you are, as a data analyst, have to be flexible enough to do experiments and try different solutions to find answers. As time passes, you will have a lot of experiences that build your creativity in some way or another. So remember, a data analyst is a creative person who tries and creates different ways to solve a problem. Next, curiosity. Webster said, at the end of the day, what you really want is someone who is curious, who enjoys drilling into data and spending a lot of time with it, hours on end, and coming up with a big insight that fuels the development of a strategy. While working on various data analysis projects, I found myself asking so many questions about the data in my hand, finding interesting answers, and then asking again new questions. I literally became a data detective. So, are you willing to be the same? Are you ready for a long journey of chasing the truth everywhere and every time? Does the possibility of failure scare you if you don't find the answers you are looking for? Finally, effective communication skills. In one of my in one of my previous job interviews, I was presenting a data analysis project to several people in the company. On one slide, I was explaining a graph, and then one of the audience told me, I don't get the meaning of the graph. What are you trying to say? At that moment, I realized that storytelling is definitely a skill that I should work on it more. Zhang said, storytelling is a very important skill to be able to translate numbers, the metrics, into clear and straightforward and actually engaging stories. So, why should a data analyst care about communication? The simple, direct answer is to make people trust your results. No one will trust your numbers and graphs if you don't know how to explain them well. Therefore, remember communication, then communication, and finally communication. So now let us discuss another set of skills that are needed for a data analyst. Continuous learning and statistical and technical expertise. Let's first talk about continuous learning. Through my learning journey, I faced many knowledge challenges I didn't know how to overcome. I put my effort and time to solve projects I have never done before. In all my work, I had to search and find articles, videos, and courses. Eventually, I found myself in an unending loop of continuous learning. At first, I thought that I'm doing something wrong. Is this normal for any data analyst? And even on other days, I found myself forgetting how I solved a previous challenge. I had to go back through my previous work and study it again. Then I reached the conclusion that it's not totally normal. A data analyst must be always hungry for more and more, as data is growing more and more at every second. Second, statistical and technical expertise. Should I know statistics? What should I learn first? Python or R? All these questions and others are very important to be answered before you dig deep in the data analysis and become an expert. Many people in this process will feel lost and eventually walk away because they cannot clear this chaos. My answers for all the above questions are the following. Yes, you have to learn statistics continuously. It is normal to forget what you learn, but do your best to build a strong statistical background. For the question, which programming languages should I start to learn? You should specify your objectives. Do you want to start a new career? If yes, then study the market very well. If you know R, you may not use it because the IT department team in the company prefers Python and vice versa. Note, this is just a self-made example and not a real fact. On the other hand, if you want to work as a freelancer, you will need also to study the market and find a gap that you can fulfill. There is no certain answer. It actually depends on what objectives you want to work on. Final note for you to remember. There is no perfect programming language. All programming languages serve different purposes. So please be very clear of what you are trying to achieve. So now you might wonder how to start studying for data analysis. First, you have to learn about programming. It's written here, it's optional. It's optional because some of you are beginners, some of you are intermediate. So for you as a beginner, it's very good for you to learn how to program using C++ or C Sharp or etc. But mainly you have to learn Python because Python is the language used for data wrangling, data gathering, data cleaning, uh, data visualization. Then you have to learn SQL, how to write a query in SQL to get data from the SQL database. Database design, it's optional here. If you don't have a data engineering team, it's good to know how to design a database and get data from this database. Then you have to learn about statistics. It's very important skill for you to learn. Then comes R language. It's optional to study R. R is mainly used for statistical purposes. Python is mandatory more than R. Then you have to learn how to do data wrangling or data cleaning. It's very important for you to know how to deal with missing data, for example. There are issues in the data. Also, you have to learn how to tell stories about your data using Power BI or using Tableau or Infogram or any other software that helps you to draw visualization for your data. Finally, you have to know how to do data analysis in Excel because it's mandatory in many companies to work in Excel. So now you might wonder how to start studying for data analysis. If you want to start studying for data analysis, I recommend you to enroll in any of these platforms like Udacity, iNeuron, 365 Data Science, DataCamp, and DataQuest. So let me talk about each of them individually. Udacity is a platform that provides you with many types of courses related to technology, business, and etc. One of them, they have the Data Analysis Nano Degree. This program includes recorded videos, short quizzes, and handed-on projects. So this is for Udacity. For iNeuron, they provide you with recorded videos and short assignments to work on. For 365 Data Science, they provide you with short recorded videos and quizzes, short quizzes to work on. For DataCamp includes everything you need. They provide you with recorded videos about the lessons related to data science and also quizzes and projects to work on, guided projects and unguided projects. And also they provide you with, you can practice data science skills on their platforms on daily basis. For DataQuest, they provide you with handwritten lessons related to data science and quizzes to work on and practices in addition to projects. What certificates are available for a data analyst? For a data analyst, there are so many certificates available like Certified Analytics Professional, SAP, Azure Data Scientist Associate, Microsoft Certified Data Analyst Associate, and etc. So you can pick any of these and add it to your CV. It will be a very remarkable thing to do in order for you to get a job in the data analysis field. So now you might wonder, what books should I read as a data analyst? As a data analyst, you have so many options to pick from. For example, you have this book called Microsoft Excel Data Analysis for Dummies. In this book, you will learn how to do data analysis using Excel. The second book called Head First Data Analysis. In this book, you will learn how to think as a data analyst, how to ask the right questions and get fruitful answers. The third book called Data Science for Business. In this book, you will learn how to apply data science or data analysis in business context. So from the picture, you can see other books mentioned here. You can pick from and start reading. So I hope you all have enjoyed the course, and I hope that you found the answer to your question. Is data analysis is the perfect fit for me? See you in next courses, and thank you all.